We ready? All right, on to the vote. A, B, or C. So A, B, or C. Ready, set, vote. You gotta vote for something else? Don't look at her and vote. I saw you. Be your own person. Okay, we gotta vote. All right. The answer is this. It is A. Okay? It can't be B, right? Because B means that nothing happened. Why is it not C? Because it's a polyatomic ion and you're a home wrecker. Look at what you did. You took these 4 children away from their poor mama. Why you want to do that? Don't break apart polyatomic ions. You got to right? I didn't ask you to know what that is, but you got to start to recognize these guys as polyatomic ions, right? We've seen phosphate, sulfate a lot. Nitrate, we see those a lot. So you got to start to at least recognize what they are. You might not know the charge or anything else, but you got to recognize that's a polyatomic ion and I can't break it apart. Don't be a home wrecker. Okay? We got enough issues in the world without you doing that. So, think about this one real quick and we'll vote on it. Now you got a 25% chance of getting this right. Actually, you should get this one right. It's a strong electrolyte. Everybody ready to vote on this one? There's only one answer that's even remotely close to being right. Everybody ready? Yeah. 1, 2, 3, or 4. Okay, ready, set, vote. No? Megan, you don't see it?
Well, I thought I saw it, but I'm not sure.
All right, look. What does it mean to be strong electrolyte? It forms what in solution? Strong electrolytes form ions in solution. Which one of those up there has ions as a product? That's the only one that has ions as a product,
I had
isn't
it
it?
right, but I said it again. Is that what it was? I promise.
It's the only one that disassociated, the only one that formed ions. The other one didn't do anything. The first one is a combination reaction, right? That's definitely not dissociated. Okay. These are a little bit harder. I want y'all to work on for a minute. Write an equation for each one of these. The first one's a strong electrolyte, the second one's weak, and the last one is a non-electrolyte. So write an equation for it, for each one of them. Which it's probably not even in your chart of polyatomic ions, but you should be able to figure out the charge on it. It says strong electrolyte. So what do I get? Potassium, right? What's potassium? What's the charge on potassium, y'all? Plus. And that means it's aqueous. How many of them do I have from the other side? 2. So I'm going to put a 2 right here. CrO4 is what I'm left with. What do you think the charge is on CrO4 chromate? It's negative. What? 2, right? Because I have 2 positive charges, this has to be 2 negative. So weak electrolyte, H3PO4, aqueous. And what kind of arrows did we say we use for weak electrolytes? A double-headed arrow is like this, right? And it's going to break apart. And I have 3 hydrogen ions, aqueous, plus 1 phosphate ion, and the charge on it is 3 minus. Okay?
How double arrow again?
Why is it a double arrow? Because it's a weak electrolyte.
Weak.
And then the last one, C12H22O11. Solid. Goes to give C12H22O11. What's the difference on this side? On this side, it's just going to be aqueous, right? It's exactly the same. All we've done is change from solid to aqueous.
How do you know
It says it's sugar.
that?
Sugar's not an electrolyte, it's just a polar molecule, right? We showed sugar earlier, being a non-electrolyte, right?
So if you were to take all those elements and do your electronegativity test on each one? you
For
discover-
this?
Yeah.
No,
How do you know?
you have to know what the structure of it is to be able to see what it looks like. These are all non-metals, right?
Mhm.
And we'll talk about sugar molecules like last week of the semester.
For every non-electrolyte, is it gonna be that?
So right now, we're just gonna accept that it's non-electrolyte.
Yeah,
And it doesn't.
it's very polar. Sugar is very polar, but it's a non-electrolyte. Yep. So, when you hear about, anybody ever gone to the hospital and looked at a IV bag? Have you read it? You look at it? The units that they have on there are how many equivalents are in there. Okay, it doesn't say anything about how many what the mass of the things are. It says how many equivalents. An equivalent is a measure of how much electrical charge there is. So 1 mole of positive charge is 1 equivalent. 1 mole of negative charge is 1 equivalent. Okay? The charge of the positive ions must always, always, always balance the charge of negative ions. So if I have 5 equivalents of positive charge, how many equivalents of negative charge do I have? 5. Okay? You must always have the same number of positives and negatives. Okay? You cannot have more of one or the other. And you will also see milli equivalents used normally as opposed to full equivalents. Milli just means like we've always done. Milli means 1/1000. Like a milliliter is 1,000th of a liter. A milli equivalent is 1,000th of an equivalent. Okay?
What was the definition again? A measure of.
Is how much electrical charge basically is in there. Okay? 1 mole of electrical charge is 1 equivalent. Okay? So here's an example. We have 25 milliequivalents of sodium, 4 milliequivalents of potassium. We have a total of 29 milliequivalents of positive charge. Automatically, I know I must have 29 milliequivalents of negative charge. Since the only thing that's there is chloride, it must have 29 milliequivalents of chloride in there, of charge from chloride. Okay? Does that make sense? Now look down here on the bottom, this chart. Sodium is +1, right, or 1 plus.
Yeah.
Calcium is 2 plus. So if I have 1 mole of sodium and 1 mole of calcium, sodium only provides 1 equivalent of charge, but 1 mole of calcium would provide 2 equivalents of charge. Because the charge is 2, right? If I had iron, I would have 3 equivalents of charge for iron 3. Yes?
Would you need, if you did the calcium and the sodium together, would you need 2 sodiums?
No, because they're both positive. I'm going to add those up, and then I would have to have 3 equivalents of negatives from someplace. So if I had 1 mole of sodium and 1 mole of calcium, I would have to have 3 moles of chloride to make that equal, right? Because 1 mole of sodium plus 1 mole of calcium gives me 3 equivalents. Because calcium provides twice as much charge. Okay?